Hi everyone, thank you for having me here. I'm Peifan Wu, and I'm a postdoc fellow at Vancouver School of Economics, the University of British Columbia. I'm proud to introduce QuantEcon Data Science, interactive online data science course website to you all. In the following 2 minutes, I'll first briefly talk about the structure of the course contents. Then I'll show you how they are deployed on Jupyter Hubs and the benefit of it. The QuantEcon Data Science course consists of Python programming, introduction to data science, and case studies with economic methods. In the first 3 parts, we introduce Python syntax, the usages of NumPy and SciPy, and pandas data frame manipulations. The last part, applications, are case studies that apply the previous techniques to specific problems with econometrics and basic machine learning tools. We hosted the course material on several Jupyter Hubs so the users can launch the notebooks by themselves. Once they launch it, they can run all of the codes by themselves, and it becomes interactive. The UBC one is for teaching, and we do have a Google Colab one that's open to public. The lecture series is also good for self-study, as we have a Discourse forum maintained by the QuantEcon team members. Questions will get answered promptly on this forum. All the lectures are written with RST files, and the QuantEcon team developed a JuBinks tool, a tool that compiles the RST files directly to Jupyter notebooks and web pages. This makes it simple to maintain and to edit the lectures. This course is taught in the past spring. We have to switch from offline to online teaching due to COVID-19, but switching is slack for the course because of the interactive Jupyter notebooks. For more details, please check the poster. The links to QuantEcon Data Science course and to the Discourse forum, as well as the JuBinks tool, are listed there as well. Thanks again for your interest.
Hello, everyone. This is a poster presentation about the role that Jupyter can play to make the process of parameter estimation more efficient and more transparent. For real-world applications, computational models and mathematical models usually contain a set of unknown coefficients, the value of which should be determined prior to conducting the final simulations. One of the best solutions to overcome this challenge is construction of an inverse problem in which an optimization process tries to minimize the difference of the output of the model and the experimental results that we already have. One of the challenges for the final user, for the user that does this, in practical application is the user should fine-tune the search space several times. The search space is the pool out of which these parameters are taken by the optimization process to be tested in the model. Jupyter provides a very good and unified way for making this process more transparent and easier for the user. Indeed, this process involves comparing the output of different search polls multiple times. And by developing this, by implementing this in a unified notebook, the user will be able to compare these results efficiently just beside the code that has produced the results and the search poll and the configuration that is resulted in that specific output. As an example application, we have implemented a notebook in which a Bayesian optimization approach has been employed to minimize an objective function, which is the difference, as I said, the difference of the output of the computational model and experimental results. And it's available as a notebook, as a Jupyter notebook, let's say.
My name is Kriti Kohli. I'm a principal data scientist at IBM, and I'm speaking about demand sensing in the era of COVID. The spread of COVID-19 has disrupted the global and local economy significantly, and we are facing entirely new, unprecedented challenges. Traditional time series methods relying on historical data alone are no longer accurate in response to COVID-19 demand shifts. High demand volatility has made it very challenging to be able to take corrective operational actions in a timely manner. We use deep learning and time series models to create the Disruption Recovery Index, which predicts volatility in local economic activities. The Disruption Recovery Index leverages localized information of COVID conditions along with market and macroeconomic data to track how consumer behavior is tracking to the disease conditions. Another way to identify consumer behavior is to use social media data. For example, even if retail stores are open, what's the probability that consumers will feel safe to go there? We subselect and identify posts of interest using a nearest neighbor algorithm and then use NLP transfer learning to identify the probability of any post expressing various sentiments. Using Jupyter Notebooks on IBM Cloud allowed us to develop this platform very quickly and gave us the flexibility to iterate ideas. Being able to share working code among the tech teams sped up the development process, and while having client-ready visuals embedded within the notebook gave us the ability to produce working prototypes in record time. Jupyter on Watson Studio reduced the process of producing a client-ready demo from weeks to hours. Finally, we use these disruption insights in demand forecasting models where we use time segmentation methods along with time series, machine learning, and milestone models to combine trends and consumption changes during COVID to create a comprehensive view of demand in the new normal. If you'd like to learn more, please feel free to get in touch with me.
Hello, I'm David Lippert, a data engineer at a company called Leidos. This summer I ran our intern program. I decided to teach the interns about one of my passions, FIRE, financial independence, retire early. The FIRE movement believes that if you minimize your spending and maximize your investing, you can retire long before the standard retirement age of 65. In fact, many FIRE followers have retired in their 30s. I created a lesson plan for the interns with Jupyter Notebooks using interactive widgets. I also relied on Pandas for data and Matplotlib for visualizations. My goal was to engage the interns and allow them to use their own financial estimates and play with multiple scenarios to get a better understanding of how compound interest and investing can work for them. My first interactive widget shows you how much money you can give your future self if you save and invest. You can see how much your money can grow with the magic of compound interest and compare the difference between investing or putting your money under your mattress. The play button was surprisingly easy to set up, and you can change the speed in which it plays. My second widget is a simple FIRE calculator that allows you to enter a few variables and then see what age you might be able to retire. The idea is that people will find lessons more compelling if they can enter values that match their personal circumstances. In my case, the interns were able to add things like school debt, different salary and spending amounts, and they especially seemed to enjoy the interactive parts of the lesson. Interactive widgets were a fairly easy part of building these lessons, though I didn't mess around too much with widget layout. But overall, I think Matplotlib has a lot of power if you have the patience. Thanks so much for listening. Feel free to look at my notebooks and borrow any code. I also have links to some of my favorite FIRE resources. The interactive widgets work particularly well with Voila, so I hope you're able to see for yourself and get ideas for how you might incorporate interactive widgets into your own lessons, or just see when you might be able to become financially independent. Thank you.
Hi, I'm Ryan Cooper. I've been using Jupyter to build a student-centered learning community here at University of Connecticut Mechanical Engineering Department. Education is not a preparation for life. Education is life itself. It requires community, communication, and problem-solving skills. Jupyter provides an ideal environment to create content that is student-centered. What I've done is create 5 different learning modules with over 20 Jupyter notebooks and hosted those on GitHub. The students have access to a Jupyter Hub server that has Docker containers for each of them. Each learning module consists of 8 steps through the learning process. The first step is to recognize previous knowledge. The second step is to introduce a new model. The third step is going through the problem-based solutions. In step 4, the students are given a project, where in step 5, the students actually create a solution. Step 6, they share their work and get feedback from other students. Step 7, they submit their work to myself and the TAs. And 8, they're ready for the next module because they have these new skills and new knowledge. The results from this process were amazing. Students made excellent progress, increasing their comfort with Python. And they said they wish they had taken this class earlier. So in conclusion, Jupyter just makes coding fun. It makes problem solving fun, and it turns the classroom into a development environment. Students need this kind of student-centered learning in order to apply what they know to something new and actually gain some new knowledge. So they need this community, and they need this practice of actually getting experience doing things. And Jupyter is a really great resource to actually creating this student-centered learning community.
Hi, my name is Robert Roska, and I'll be introducing Oscovita, the Open Science COVID-19 data analysis project. Oscovita itself is a Python project, which lets you download coronavirus numbers worldwide. Oscovita also provides some convenient statistics and plotting functions, so that you can quickly get a feel for the data and have something to build on top of for your own analysis. Using Jupyter, we created a report template with the Oscovita package. The report covers a number of useful plots and statistics, which give you a quick overview of the state of coronavirus for a region. As well as the report, we also created a number of tutorial and educational notebooks, which help explain what the report says, as well as how the data in the reports was computed and why it's important. The notebooks also explore some potential avenues for further analysis, such as correlations between confirmed new cases and holiday periods. We then use GitHub Workflows, as well as a static site generator, to automatically execute all of the reports twice a day, and to build a website which hosts them for ease of access. As the reports were originally created from notebooks, it is also possible to execute them via Binder, allowing those who are interested to easily explore the data further themselves without having to set up the environment. Thank you for listening. Hope you enjoy looking through the posters.
Hi, I'm Anne. I'm working at the University of Oslo in Norway, and I will talk about the Climate Jupyter Lab as an interactive tool in Galaxy. So first, the motivation to develop and improve climate models. Both modelers and observers need to collaborate. But climate modelers, they usually have very good programming skills. They are running climate models and data analysis on high-performance computers with very large scale and generating large amount of data, while observers, so for instance, field ecologists, are going into the field or in the lab, making experiments and using Excel and commercial software. So very low programming skills. So we have decided as a meeting point to use Galaxy. Galaxy is an open web-based platform for accessible, reproducible, and transparent computational research. We have added a new interactive tool, which is a Galaxy Climate Jupyter Lab. With all the Pangeo software stack, it is our co-design platform, and eventually we would like to offer new Galaxy tools, for instance, Voila Dashboard or parameterized notebook using Papermill, so we can deploy and run as Galaxy workflow for reproducible research. As shown here, we can execute and publish workflows. If you have any questions and comments, or if you want to provide help and support, please contact me. Thank you.
Hi, welcome to my presentation about X-ray leaflet, big geodata visualization in the Jupyter Notebook. I'm David Brochard, and I am a scientific software developer at Quantstack. In this talk, we will try and visualize a dataset, which is river stream flow for South America. Let's first open the dataset with X-ray and plot it with the built-in plotting capabilities, which under the hood uses Matplotlib. As you can see, we can barely see anything. We have another option, which is to use API-MPL, which is the interactive version of Matplotlib in the browser. This gives us more interactivity, especially we can zoom in. And as you can see, we are starting to recognize rivers. Let's now use Xarray Leaflet. Xarray Leaflet gives us some more flexibility to transform our data through a data pipeline. And we have also much more interactivity. As you can see, we can zoom in and pan, and it's much more responsive. Xarray Leaflet also gives us the ability to reveal more data depending on the zoom level and the position you are in using dynamic maps. For example, if I zoom in this dark area, you can see that data is being revealed. This is basically just updating the color map in this case. This was just a small introduction to Xarray Leaflet. You can see more on the GitHub account here. Thank you.
Hello and welcome to our poster. My name is Stefan Siemen. I'm from the European Centre for Medium Range Weather Forecasts. And we from ECMWF would like to share with you a little bit of the experiences we have working with Jupyter Notebooks, but also a little bit of some of the new developments we have in this area. So the poster is divided in two parts. On the left, you will find a bit more about why we use Jupyter Notebooks, our motivation, but also in the areas we're using it, like training on data, services, and our software. Also a bit what we show is that what we really like about Jupyter Notebooks and the integration with so many servers like Mindbinder or the Gaggle competition webpage are really very nice, and we like this. On the right side, you find a bit more about our new developments. So we have a lot of tools and software to help users to work with our data, especially in Python. But these are still very domain specific. So recently we started a new package called Climate Lab, which really tries to address this for the cross-discipline scientists wanting to work with our data. So have a go and have a look. You will find it's very well integrated with the SciPy ecosystem, and all the documentation and examples are in Jupyter Notebooks, which makes it quite easy and nice to work with. Further, at ECMWF, we have started building our own Jupyter Hub environment. It's all based on Kubernetes, and we built distinct user environments in Docker images, which we deploy through a CI/CD pipeline, so allowing the latest software to be used by users in our notebooks. Last but not least, in the bottom right, you will find some details how you can engage with us, and we hope to hear from you. Either question, comments, please let us know. Thank you very much.
Hi. How many times reproducing an analysis has been extremely frustrating because the amount of time spent on that process was far too long. If research was fully reproducible, this process would be simplified and it would probably guarantee much higher scientific standards. Although the infrastructure to go in the direction of fully reproducible research is there, not all scientists are aware of state-of-the-art technologies to develop code following the best computational practices. And researchers in our field, hydrometeorology, are not different from others. We want to show how Jupyter Notebooks can help scientists to be flexible in their code by allowing them to use the most appropriate tools or languages for their analysis, including niche languages like MetView. We also want to show how by integrating Jupyter Notebooks with other platforms like GitHub, Zenodo, and Binder, it is possible to create an end-to-end research workflow and allow a quick and easy deployment on the cloud of our work for other researchers to interact with it directly from a web browser. If you want to know more, we invite you to see our poster. But first, let's learn something about MetView.
MetView is ECMWF's open source software for handling meteorological data, with an emphasis on WMO formats such as Crib and Buffer, but also more widely used formats such as NetCDF and CSV. Its graphical user interface provides a fantastic environment for interactive data plotting and analysis. Its Python interface adds a massive library of high-level functions for processing this data, And it's this that allows MetView to work with the rest of the scientific Python ecosystem, making it ideal to run in Jupyter notebooks. And with easy installation through Conda and pip, it's quick to create an environment and platforms such as Binder to allow others to run these notebooks.
Welcome. We would like to invite you to join us in a poster discussion about a project called Jupyter Meets the Earth. We're a collaborative community of scientists at UC Berkeley and NCAR has joined forces with software engineers in a variety of locations to basically establish a very collaborative co-design process where research use cases in the sciences and geoscience in particular motivate software developments in Jupyter and Pangeo, with both the science and the software aspects playing equal and complementary roles. This effort is built on top of the Pangeo project, which uses not just Jupyter for interactivity, but tools like Dask and Xarray to enable large-scale interactive data analysis of Earth science data. This is an example of the kind of workflow that is enabled by Pangeo, where a scientist may zoom on an image, and after a few seconds, that image resolves better. This is the kind of thing that happens in our phones all the time. In this case, it requires processing 100 gigs of data on a distributed Dask cluster. We want scientists to be able to do this as a routine matter in their workflow without having to become effectively cloud engineers. And Pangeo enables this. And once we bring together data and common infrastructure like Jupyter and Pangeo in the cloud, what we create are spaces that can act as scientific watering holes, if you will, where diverse communities of participants can come together to work on new problems with these data and these common tools, where they can go do everything from early exploration and discovery all the way to publication and public engagement, and where they can view two kinds of resources that are important in science, which are supercomputing type facilities and cloud computing infrastructure, just as part of a common spectrum of tools that they can choose to use depending on which fits their needs better, but where the open infrastructure sort of unifies these kinds of resources for them. And we've seen the impact of this already in events like the various geoscience-related hack weeks and hackathons that have occurred over the last couple of years that validate that this approach is really powerful and hopefully will carry on to other disciplines. So we invite you to come to our poster session, meet our community, ask us questions, and more importantly, tell us how we can make this project serve your needs better. Thank you very much.
Hello, everybody. Thank you very much for choosing to view my poster presentation. My name is Robert Nikuta. I am the project scientist for the Astro Data Lab Science Platform, which is developed at NSF's National Optical Infrared Astronomy Research Laboratory. We are based in Tucson, Arizona. Astronomy has fully entered the era of really big data. At Data Lab, we host almost 100 terabytes of astronomical catalogs and provide access to several petabytes of astronomical science images. My poster shows how at Data Lab we employ Jupyter notebooks to access and analyze these large data holdings. This is possible because of co-location of big data with compute resources, and this is indeed the major difference between a traditional data archive and a science platform. You never need to download any data, but you can instead perform queries, run data reduction and analysis, and visualization tasks right on the same platform. You do all this remotely using nothing but a web browser. As a great way to teach our users, at Data Lab we develop a large set of example notebooks, which every user receives with their account. The notebooks range from introductory level, through complete science examples, technical how-tos, to notebooks geared towards education and public outreach. We also welcome user contributions and help users to get their notebooks accepted into the collection. We develop the notebooks on GitHub, and when a merge into the master branch is approved, a webhook is triggered to automate deployment onto our platform. We also need to make sure that the notebooks continue to execute correctly at all times. This can be a challenge since the datasets and the middleware software are being updated often. To help with testing, we have developed a workflow based on NB-convert and wrapped it in a Python package to make testing really easy. If you are interested to learn more, please examine my poster in detail and visit us at datalab.noao.edu, and if you like, register for a free Data Lab account. Thank you very much for listening to this presentation. Cheers!
Hello, I'm Sandrine Caburet. I'm an assistant professor at Université de Paris, where I teach genomics and human genetics.
Hi, my name is Pierre Poulain. I am associate professor at Université de Paris. I am a bioinformatician.
Hi everybody, I'm Claire Vandidonk, associate professor at Université de Paris, where I teach genetics, genomics, and biostatistics.
Hello everyone, my name is Jeremy, and I'm a software engineer working at Quantstack.
This project came out of the need to teach genomics analysis with real-life datasets. And we also thought that we could do much better than the good old terminal interface. So we wanted the ability to easily create many teaching environments in a reproducible and efficient way. But we also wanted to manage those environments without any DevOps Ninja skills. Together with Quantstack, we designed Plasma. Plasma requires a bare metal or virtual machine server. It is based on the Little's Jupyter Hub, with a custom extension called TLGH repo to Docker that brings fully customizable multi-environment capability into the Little Jupyter Hub. With Plasma, you can easily manage environment. To create a new one, click on the Add New, copy, paste GitHub repo with the description of the environment, give it a name, define memory and CPU limits, and click Create Environment. This environment will be available within a couple of minutes. Once the environment is built, you can define which student can access which environment. Then students have access to multiple environments that they can run within a few seconds. Plasma is available to everyone. Try it yourself. The project is fully documented and open source. See you soon.
Finding a balance between ongoing project maintenance and new feature development is always challenging to achieve for open source projects, especially since most of the open source contributors and maintainers are people that volunteer their time and knowledge into making projects better for everyone. Novelty always seems to be more exciting, and it's really tempting to tip the scale in its favor. Recognizing the importance of the little things that make up a project and the community might be a step towards equilibrating that scale. Hey, my name is Georgiana Dolocan, and I am working as a Jupyter Hub contributor in residence under the CZI Essential Open Source Software for Science grant. I became a Jovian during my outreach internship with Project Jupyter, and since then, thanks to the awesome members of the community and their mentorship, it became my residence. This poster shows the goal of the project and where to follow the journey in terms of tasks and little achievements. It also unveils the cute robots mystery and the purpose they serve. Contributor in Residence is about community, and the hope is to learn from this experience so it can be replicated for other projects or organizations. If you're curious what it's like to be a contributor in residence, or just wondering what is a contributor in residence after all, please check out this poster. Thank you!